All right, an introduction to parabolas today. Parabolas is the shape that the graph makes when you graph a quadratic equation, and there's different forms of a quadratic. The one that we're going to deal with is just called standard form, the ax squared plus the bx plus the c, and they say a can't equal 0. Here's a quick reason why a can't equal 0. If you put 0 in for a right there, and you took him times x squared, what's 0 times x squared turn out to be? 0. Like the x squared would go away. Like there went this x squared. It's no longer a quadratic then, right, if there's no x squared in it. So, and then here's how there's just some real quick questions. Like I said, today is an intro to parabolas. They want to know, hey, does this parabola open up, which makes like a smiley face looking shape, or does it open down? You can always tell by the a value. It's cool that the a value is the number in front of x squared in that guy. So if the a value is positive, this parabola is going to open up. And if the a value is negative, this parabola is going to open down in that case. So let's just kind of go through each one of these rules as we go through the question. Here is a parabola that they would like us to think about. Let's talk. Who's A? Not quite X, right? It's got to be a number. A, B, and C are numbers. So A is 1. It's the number in front of x squared, right? B is -8, and C is 7. They want to know, does this parabola open up or open down? Right? So it's all about your a value. If your a value is positive, it will open up. If your a value is negative, it will open down. What do you think? Open up or open down? Open up. Boom. We shall circle that. And what I'm going to do, because we are very much rookies at this, is I'm going to sketch a little picture of that off to the side. It's just a parabola that opens up, like, how do you feel about that? Isn't that a parabola? You do the same thing. Is that a parabola that opens up, right? They asked, does it have a maximum or a minimum point? Well, that's that thing called the vertex. The vertex is where the graph changes from either increasing to decreasing or vice versa. What do you think that blue dot right there would be as the vertex? More like the maximum, that's like the highest the graph ever got, or more like the minimum, like that's like the lowest the graph ever got? That is the minimum in this case, right? So we'll circle minimum. Then they say find the vertex. Okay, we better go back up to a little cheat sheet up here and say how to find the vertex. There is a formula for that it would be in your best interest, the sooner you get it memorized, the better your math life will be, because there's lots of vertexes coming your way in this guy. It's to find the x value of the vertex. You know, like as an ordered pair, it's like x comma y, like that's what we're looking for. To find the x value of the vertex, here's how I want to say this. The opposite of B over 2 times A. Oh, all right. So to find the x value of the vertex, I am going to make us also write that formula down every time. Yes, we'll say it out loud a lot, and if you write it, you'll also learn it really good. So opposite of B over 2 times A. Cool? So notice I put x equals opposite of B over 2 times A, then another equals. Now I'm going to go and start putting my numbers in there. B, you told me, is -8. I need the opposite of that. What is the opposite of -8? +8. 2 times A, we can do in our head / calculator. Isn't the A value 1 in this case right here? I need 2 times that, so that would be 2. And I've tried to keep most of these nice. It is very possible that you could end up getting a fraction, but for rookies, it's nice to have whole numbers. 8 divided by 2, doesn't that totally come out nice, right? So 8 divided by 2 is 4. Cool? And then what I do after that, because that's just the x value of the vertex. So when we have to graph this parabola, we're going to have to plot the vertex first. Even on my open math, that's how you graph it, is plot the vertex first. Are you cool that the x value of that will be at 4, right? But where will the y value be? So here's how I show the work. I just start writing my ordered pair right here. And it's the hardest thing for people to realize at first. It's how do I find what the y value of the vertex is? How do I find what the y value of the vertex is? How do I find that? What does this say right there? Y equals. That will tell you what y equals in any type of scenario in this equation if you know the x value. Do we know the x value of the vertex? 4. We need to substitute 4 in for x. Grab your calculator, because here is the trick. Please believe me, this is serious. You need to, let's do this on paper first. You need to put 4 in for x into parentheses. right? You've got to put it in parentheses. So I went and put parentheses around every one of those x's, and now let's substitute that guy in. Sorry, I didn't have my calculator open. You can start typing parenthesis 4 squared. Like, you got to close the parenthesis first. So 4 went in the parentheses. Squared. Do you know how to square something? Like, there's sometimes is a squared button, or you could raise it to the second power. Ask your neighbor if you need a little help. Minus 8 times 4, and then what does it say at the end? Plus 7. Are you cool that I literally just retyped our equation that was provided for us, but where there was an x, I like put 4 in parentheses. Yes? Cool. What did you get for the y value of the vertex? -9. So here's what we know so far. We're going to make a parabola. It's going to open up. It's going to have a minimum. The minimum is going to be right there at 4, -9. That is the vertex of this parabola. That's the lowest this graph will ever go. Cool? So, part C, new concept. Find the y-intercept. When you get confused on homework, look back to this sheet. It'll tell you how to find the y-intercept. We did that long time ago, and it was so easy that we only had to do it for like a day. And then when you haven't done it for a long time, it's been a while. But if you remember, like, y-intercepts are just like these points right here. What is the x value of every one of these points right here? X is how much? 0. You just put 0 in for x into your equation. So if I put 0 in for x right there, hey, we're smart. What's 0 squared? 0. You're going to get nothing there. Minus 8 times 0. What's -8 times 0? Would you believe everything I've highlighted in orange is going to disappear because you just put 0 in for x? Plus 7. What do you got? Yep, but as an ordered pair, we'll do 0, 7. Uh-oh, I hit the wrong thing there. So 0, 7. I don't know if homework's going to make you type 0, 7, or if it's just going to be 7, right? So just kind of pay attention. Do they want it as an ordered pair, or do they want it as a y value in that? But now here's the fun. Find the x-intercepts. Here's the shortcut. I shouldn't say shortcut. Let y equal 0. All right, so I'll do that in this equation. I'm going to rewrite this whole bad boy right here, but I'm going to put 0 in for y. And here we go. Yay! Do you see how I put 0 in for y? I need to solve this for x. Is this a quadratic equation? Yes or no? Is it ready to run, aka equals 0? Cool. Let's talk ourselves through the factoring cheat sheet. Is there a GCF you could take out of those 3 guys? Nope. How many terms does it have? 2 terms or 3 terms? 3 terms, so it is not the 2-term guy, which is the difference of squares, right? So first thing I'll look for, perfect square trinomial. First guy, oh yeah, he's a perfect square. Last guy, is 7 a perfect square? 7 a perfect square? Nope, so not going to happen. So it's down to easy or frowny face. What do you want, easy or frowny face? It's all about the a value. A value is 1. I'm going to easy factor this. Find 2 numbers that multiply together to be 7 or 8. What do you want? It's got to be the c value, right? It's got to be this guy, right? It's got to be that dude. 2 numbers that multiply together to be 7, add together to be not quite 8, but -8. Find those 2 numbers. What's their signs? Both negative, right? So what do you think? 1 and 7, but both negative. Hey, could you do this if you were a little confused? Because I saw we were a little confused, which is normal, right? It's like, I don't know what they're supposed to multiply. Could you do this? Boom. Could you do that? What do those 2 numbers right there multiply together to be? Isn't that a 1 right there if you wanted to frowny face this, right? So would you get a 7 up there? Yes or no? You could do that. It takes a little practice that you don't have to when the a value is 1 in that case, because 1 times 7 is still 7, right? Are you with me on that? So if the multiply together to be 7, add together to be -8. Do you want me to go through all of that work of like writing it as 4 terms, double grouping it, taking the GCF out of each group, or is it faster than that? This is easy factor. Do we want to frowny face it, or do we want to easy factor it? So it's just going to be 0 equals these 2 groups, and you know our 2 bingo numbers that we found right here? X minus 1 and x minus 7. But that does not answer anything. We have just made this equation that was quadratic easier to solve because we have gotten rid of all the stupid x squareds. Can we use the zero product property to solve for x? Cool. What would x equal in this guy? What value of x would make that 0 if x was 1, or if x was 7? So they might want you to write those as ordered pairs. It would be 1, 0 and 7, 0. Like, isn't those two different ordered pairs? Sorry, I'll screw that up a little bit. 1, 0 and 7, 0, because those are x values. And then part E says, yo, bro, you've got enough information to make a really accurate sketch of your parabola now. Let's start by plotting the vertex. Where was the vertex? What ordered pair? 4, -9. Been a while since we plotted a point. Give it a try. See if you put it in the right spot. 4, -9. I don't even want to do it wrong. You got to go to 4 on the x-axis and -9 down here. I understand you may have accidentally put that in the wrong place, but 4, -9 is right there. Then let's plot the y-intercept. What's the y-intercept? 0, 7. That's way up here, right? And let's plot our two x-intercepts. One of them is at 1, 0, and the other one is at 7, 0. Are you cool? That those are the 4 points that they had us find. When we connect these together, will it make a line? No, it will make a parabola. Isn't the vertex a minimum of this guy as well, right? So here's what I do. You just freehand it. You are not allowed to use a straight edge to make a parabola because it's not straight. It's curved in that case. So it's going to be kind of ugly at first when you're not used to it, but I'm going to start down here, and I've got to go through that guy, and it's going to go up forever, so I'm going to put an arrowhead on it. But then this is the hard part, is getting your little sketch to go through those other points. It's got to go through that and that. So if you swing and miss, use an eraser and fix it. It doesn't have to be perfect. Mine's probably not that good looking either because it's a little too squiggly, it doesn't curve the way it should. But it's close enough, right? It gets the point across. Is that all right? So that is a parabola. Which way did it open, up or down? Up. A value was positive, right? So let's try that again. That was kind of weird. Let's go through all these steps again. First, notice who A, B, and C are. And you tell me, who is A? -3. Will this parabola open up or open down? It will open down because that is a negative A value in that case. Make a little baby sketch off to the side of a parabola open and down because it will visually show you what that vertex is. Is that vertex a maximum or a minimum? It is a maximum. Those are so strange because down sounds like minimum. It's like, oh, it opens down, so it should have a minimum. It's opposite game on that stuff. Are you cool with how to tell the openness of a parabola? Find the vertex. Better look it up, right? There's a little formula. We shall find the x value of the vertex with the little formula. Yes, I'm going to make you write it down. Opposite of b over 2 times a. And just be careful, right? b is 12. Are we all good with that? I need the opposite of that. What is the opposite of 12? -12. Does that make sense? Like the opposite, like change your sign, right? 2 times a, well, a is -3, right? I need 2 times that, so that should give me -6. Are we all good in the neighborhood? Everyone in here knows this answer if I ask it out loud. It is amazing if I don't ask it. What happens? What's a negative divided by a negative turn out to be? Positive. You all know that, right? So that will be 2. That is the x value of the vertex. We're usually very good at finding that because we have a formula for it. But it's like, how do you find the y value of the vertex? How do you do that? You sub it into the formula into parentheses. So we're going to literally type what we see, -3. Wherever there is an x, please put that in parentheses. So plus 12 times 2 minus 9. Do you see where there was an x, I put a 2 into parentheses. Rock on? And it should come out to make some sense. Sometimes we hit the wrong button. Sometimes we forget to square the first little guy right there. It's going to happen. Like a little bit of common sense, because we're still new at this, is if it's not going to fit on the graph that I gave you, you probably made a typo. You know what I mean? It's true, I've made some typos too, you know, like on your worksheet. So it's like, this one doesn't fit. And I'll be like, yeah, sorry, that's the correct vertex. But I would say 99% of the time, we're in good shape. So 2, 3. Find the y-intercept. It is usually such an easy thing that it becomes hard. How do you find the y-intercept? You let x equal 0. Let x equal 0. So I'm going back to my equation, and wherever there is an x, I'm going to put 0 in its place. Doesn't it just make those two blue blobs disappear, right? Who is the y-intercept? So shortcut, isn't it the constant term, right? It's always going to be that number right there. Does that kind of make sense? So -9, we'll write it as an ordered pair, 0, -9. And now for the new interesting twist. Let's find the x-intercepts. How do we do that? We let y equal 0. So I'm going to put that up here. 0 equals -3x squared plus 12x minus 9. I put 0 in for y. And I need to slow us down. We're going to talk this in phases. Let's, you and a neighbor, discuss how would you factor that. To record. Our class has discovered that frowny facing is an option, but it's a bad option because there is a GCF that we could take out of these three terms. What would you like to take out for the GCF? 3? Watch me do it. Good choice, not the best choice. If I take out a 3, what would this turn out to be right here? It would be a -x squared, which kind of sucks because you're still going to have to frowny face that then. Do you know what I mean? I need that to be 1 so I could easy factor it. So instead of taking out a +3, what could we take out for a GCF instead? If you take out the negative, then you don't have to do the frowny face stuff. So the goal now that we've learned all the types of factoring is, holy crap, bro, if I could ever get a 1 in front of the x squared, that will be easier for my brain to deal with. Not that it's hard to do the other stuff, it's just weird. So let's factor out a -3. And that would mean you have to take a -3 divided by a -3. Don't you get your +1 right there? And the x squared comes down with the ride. Then 12 divided by -3. What do you want to put next? Not 4. It's a -4. The signs are going to kick our butts, right? So we got to be very careful with the signs, right? So -4. And then what would this turn out to be right here? Negative divided by negative is a what? +3. And then what I'm going to do is be very nice. Don't forget we got to put the equals 0 at the beginning or at the end. What I'm going to do is also be very, very nice to you. Let's pretend that you couldn't find the two numbers. Isn't our job right now to find two numbers that multiply together to be 3 and add together to be -4? Let's pretend you couldn't find those two numbers. You are doing it wrong because I have made everything this chapter factorable. But when we get to chapter 9, not everything will be factorable. We'll have to learn other ways to do it. So like, just like if that was a -3 right there, you know, there is absolutely no way you could find two numbers to be a negative, multiply together to be a -3 and add together to be -4. Because it's 1 and -3 or -1 and 3. Those are the only two combos that add together, multiply together to be -3, and neither of them add together to be -4, right? So what people do is they just pretend to make it work. They're like, well, I'm going to do that then because those add together to be -4. Well, don't they now multiply together to be +3, right? So you can't do that. But anyway, we didn't make a sign error. Isn't this a +3? Who are our two numbers? -1 and -3. But what happens to this? He hasn't been there yet. What happens to this? He just comes along for the ride. Are you with me? He comes along for the ride. So I'm going to have 0 equals that weird -3 on the outside. And remember, this is easy factoring. We looked like we were amazingly awesome at frowny face factoring. Don't do it unless you have to, right? We're going to easy factor it to be x minus 1 times x minus 3. And we'll use the zero product property to solve this. Question for you. Does this guy matter? Does he have x's with it? What value of x would make that 0? If x was 3. Next question. Does this guy matter? Does he have x's with him? Yes. What value of x would make that 0? 1. And finally, does this guy matter? Does he have x's with him? It has nothing to do with it, right? So it doesn't matter. There are our two answers. Those are our two x-intercepts 3, 0, or 1, 0. You'll probably have to separate them with a comma on homework. They said find the x-intercepts, so I did, and I wrote them as ordered pairs. So let's plot them, and I want to plot them like you're going to do it on homework. Sound good? To graph a parabola on My Open Math, you have to plot the vertex first. Otherwise, it's not going to work. So who was the vertex? Who is the vertex, I should say? 2, 3. Plot him first. 2, 3. Remember, this parabola is going to open down, right? So are we cool that you would click that dot first on homework? Then it's just going to make you pick one other point on it. We have 3 more, don't we have? This guy, and this guy, and this guy. It's going to just make you plot one more point on the parabola, right? So you would just pick any one of those. It doesn't matter, right? And it would do the parabola correctly for you. On paper, we got to graph them all. So 0, -9 is like right there. 3, 0 is like right there. And 1, 0 is like right there. Little skinny parabola. Which way is he open again? Just so your brain knows how you're connecting these dots together. Which way is he open? Down. Remember, the vertex is the maximum of this guy. So bada boom, bada boom. Please put arrowheads on them and make them go through the grid. Do you see, like, the grid stopped, like, right there? And I made the arrows just keep on going down to Chinatown. So. How do you feel about those? I only got 2 of them, right? Do we feel okay with those? Like, the box that I typed up here at the top of the worksheet will help you. It's like, I need to find the y-intercept. How do I do that? Look it up, right? And if you still need help with it, then I'll help you. But the last 2 questions are about Newton's law. You will have questions on the test about this, and you kind of got to know the formula. It's a little weird, right? And it's got these fancy schmancy things in there. They got rid of x's, right? And they talked about t for time in seconds. There's 2 main players in this formula that they have to tell you about. Is first, this v stands for the initial velocity. How hard was this object thrown? It could be an apple. It could be a baseball. It could be a bullet coming out of a gun. It could be a cannonball. It's called a projectile, something that gets projected, you know, like through the air, right? A projectile. And then there's weird things here because there is an h in this formula, which stands for just plain Jane height. There is also an h sub 0. Do you see it's like a little subscript? It's got like a 0 as a subscript. The sub 0 part means initial, so that is like your initial height. And then, because we're in America and we're going to keep this simple because it's our first go-around with this, there is this -16 that's going to be involved every time. That only works if you're measuring stuff in feet. Would you believe that, like, you could also measure stuff in meters, like most of the people do around the world, right? But that -16 is your gravity coefficient. Hey, is it positive or is it negative? Why is it negative? What does gravity do to these objects? Makes it come down, right? Are we okay with that? So here's what it is. A projectile was fired at an initial velocity, bada boom. Isn't that going to be v in this case, of 48 feet per second from a height of 288 feet in the case. I'm going to do that in pink. Isn't that the initial height that they fired this projectile on? 288 feet is way up there. Maybe they were on the top of like a skyscraper and they were shooting like a gun off of it, you know, in a wartime scenario or whatever was happening. Who knows, right? But they say use Newton's law to write a quadratic equation for this situation. So here's how we'll roll with it. We're going to start with h equals the height of this projectile, whatever it is, an apple, a bullet, or whatever, will be found at any time by -16 times t squared, where t stands for time in seconds, plus, I need to know a v value. Did they tell us the initial velocity? What is it in this case? 48. Then there's times t, right? You got to have like the t in it, plus my initial height, right? Do they tell us the initial height? Plus 288. Are you cool with, there's only 2 things you got to know to write the gravity formula, which is called Newton's law, for what's going to happen on this scenario. This is on Earth, of course. If you go to the moon or you go to Mars, gravity is a different factor and all that stuff. So are we all good with that? It says, how long did it take for the projectile to reach its what? Tell your neighbor what that says. Max height. We are pretty smart. It's okay if we can't figure it out, but where on the parabola would that be? The maximum. Starts with a V. Where would it be? The vertex. That is fancy ACT question talk for find the vertex of this parabola. Cool? Find the vertex. We have a formula to find the vertex. How do you find the x value? Look to your neighbor and tell them. The opposite of b over 2 times a. The opposite of b over 2 times a. b is 48 in this equation. I need the opposite of that. So how do you feel about negative 48? And then if you need to use a calculator, no problem. A is negative 16. I need 2 times that. What would you get for 2 times a? Negative 32. Are we okay with that? Now, let's punch that in. I'm not going to do negative 48 divided by negative 32. I already know it's going to be positive, right? I'm going to do 48 divided by 32. Does it come out pretty nice? It ain't perfect, right? But the fraction makes no sense because isn't this a story problem? It's just like, aren't they asking how long would it take? And by the way, we haven't talked about this. They're not using x's and y's. Which letter do you think represents x's? T's or h's? Aren't t's in the place? So like, let's go over to our graph and do this. This is time in seconds. And then h is where the y value usually is, right? So what do you think h stands for in this equation? The height, and they're measuring it in feet, right? So height in feet. It's very important to put the seconds in the feet because you can measure time differently, right? You can do minutes, hours, days, months, years, etc. And you can definitely measure height in meters or centimeters or inches or things like that. So height in feet. So we just found the x value of the vertex, which I'm cool that we use the letter x, even though it has nothing to do with this equation. Shouldn't it have really been t? Are you with me on that? So 1.5, put a label on that. 1.5 what? It's what t stands for. 1.5 seconds, right? So 1.5 seconds. They asked us how long would it take for the projectile to reach its maximum height. It appears, according to this math, it would take 1.5 seconds. Are you with me on that? Part C, what is the maximum height? So would you believe the x value of the vertex found us the time, because isn't that what x stands for? They now want to know what that height would be. What part of the vertex would that be? Not the x value, but the y value. Let's put it into our calculator. Let's just, wherever there was a t or an x or whatever it is, we just got to put 1.5 in parentheses. But kind of back to why I used 1.5, doesn't 1.5 seconds seem a lot more reasonable than 3/2 seconds? You know what I mean? It's like the decimal makes more sense. So 1.5, don't forget to square it, plus 48 times 1.5 plus 288. And how high would that have gotten? 324 feet. Remember, it already started 288 feet in the air, right? It was already that high. So when they threw it, it went up a ways. Sorry, I didn't want to hit the ceiling. It went up a ways, and then it had to start coming back down. Are you with me on that? So 324 what would be the label on that? Feet. And then here's the question. How long would it take for this projectile to hit the ground? We're going to make a better sketch in a second, but I want to show you what's going on. Please don't sketch this. Did this object that they're throwing start on the ground or not? So would you believe after 0 seconds, it would started like way up here at 288 feet, right? Then they threw it, it went up, and then it started coming back down. Bing. And then what's that? What happened right there? That object did what right there? It hit the ground, right? Gravity brought it down. Didn't it hit the ground? Are you cool with that? So like, what would we need to find to see when it hit the ground? That sure ain't the y-intercept. What is that guy right there? That is the x-intercept. How do you find the x-intercept? Somebody's got to be 0. Should we let x be 0 or should we let y be 0? To find the x-intercept, we let y be 0. Well, we don't have x's and y's, so how about letting h be 0? Let's see if that makes any sense. If I let h be 0, what does h stand for? Height. And I'm going to let it be 0. What's got 0 height? That's the ground. Are you with me on that? Isn't that the ground? So we're going to do it. 0 equals negative 16 t squared plus 48t plus 288. Do you see how I'm going to put 0 in for the height? He's not the initial height at all. 288 was the initial height. 0 is the height I would like to know it at, right? So we're going to have to factor this because that's the only way we know how to solve quadratics up to this point. Holy crap. Perfect square trinomial, like, starts off with a 16, or does it? Is it really a 16 in front, or is it a negative 16? Negative. I think I'd rather try to find a GCF. And here's the first number I'm trying, 16. I know we're probably going to factor out a negative, but see if 16 goes into all of those. Because wouldn't you love it if this could come out to be easy factorable to where that could turn into a 1, right? So does 48 divided by 16 come out nice? Does 288 divided by 16 come out nice? Yes. So we will factor out a 16, kind of. What do you really want to factor out so that a value turns out to be 1? A negative 16. Factor out a negative 16, baby. So that would be t squared minus probably 3. Is that right? 3t minus, what was 288 divided by negative 16 turn out to be? Negative 18. Are we okay with that? So what I love is it was a nasty little boy, and now he's an easy little boy because there's in the a value 1 in that scenario. So find two numbers that multiply together to be not quite 18. They need to multiply together to be what? Negative 18. Negative 18. And add together to be negative 3. And check those numbers with mine. And then we will just keep on factoring. That blue negative 16 on the outside does not disappear, even though he doesn't matter much. So t plus 3, right, and t minus 6 is what it factors to be, correct? So let's solve for t. And we're going to get kind of advanced here in a second. T could equal, did you get 2 answers back? What's one of the answers? Negative 3. Or, what's the other answer? 6. Well, I mean, that's algebra. The algebra says those are the 2 answers. The question asked, how long did it take for this projectile to hit the ground? Do both of those answers make sense? Because remember, this is t, right? Isn't it time? How long did it take? Negative 3 seconds or 6 seconds. Do both of those answers make sense? What do you think? Which one doesn't make any sense? The negative. So what you do is you do your algebra, right? This is just algebra on this paper right here that we've done. And then you have to, I'm going to use a fancy word, and you see it on your homework. One of these answers doesn't make sense. It's called extraneous, right? It works algebraically, but it does not fit the situation, so you will cross out the extraneous. I need to see that you have him, right? But you then cross him out, and we'll throw a label on this bad boy. Wasn't it 6 seconds? Cool? So let's go back and make our sketch. We have the labels, right? Don't we have the time and the height, right? I'll start over. Here's what I like to do. I want to put 0 on my x-axis right there for where we started. And let's go with the y-intercept. How high was this object when we initially started? So we'll put a dot up here, and we're going to put 0 to 88. Right? I'm not going to put a scale and all these tick marks and all that stuff. This is just an accurate sketch. So didn't it start after 0 seconds? It was 288 feet high. Then they threw it. Did it go up for a little bit before it came back down? Cool. So let's go to a vertex. Right? Let's go to like right there. And that took 1.5 seconds. And didn't it get 324 feet up? Right? So sorry for the bad handwriting, but I just made my vertex at 1.5, 324. And then after it has hit the vertex, she starts to come right back down, correct? And how long did that take for it to hit the ground? What did we find for our x-intercept? 6, 0. Are we okay with that? But I would like to show you this. Do you see what we have sketched is only in the first quadrant of this graph? Because this is a real-life scenario. Time can't be negative, right? But if you actually graph this parabola on a calculator, which someday you'll learn how to do, it would look like this. It would go like that blue part is like still going to be there, and you see that right here, that's at -3, 0 in that case. Isn't that other x-intercept that we had to throw away? So the parabola would be the entire thing that you see, but it doesn't make any sense because we don't have any negative time, and that thing that they did is probably not going to go underground. It could, if that was water, you know, it could go under the water. If the ground was soft and muddy and it was a real heavy object, like you threw a bowling ball off a building, it might go plunk and sink into the ground a little bit, you know. But are you with me? Like realistically, we're just using the first quadrant in this stuff. So let's try it again, man. Here's another projectile. Can you use Newton's law to write us an equation? V is the initial velocity, h sub 0 is the initial height. We feel pretty good about putting 64 in for V. The weird thing is you got to have a t next to it also, right? You know, you got to have that t. And then 192. How long did it take for the projectile to reach its what? Maximum height. Shouldn't this be a parabola when we graph it, and shouldn't it open down because the a value is negative? It should have a maximum value. Where is that at? Starts with a V, the vertex. X equals, gets you that little bitty formula that we have talked about, and find the x value of the vertex. So opposite of B over 2 times A, negative 64 over negative 32. Sorry, I kind of have all these memorized. Does that come out? Pretty darn clean right there. How long did it take for this object to reach its max height? 2 seconds. We're pretty smart. All of these are going to come out real nice because I made them factorable. Does that make sense? Most real-life scenarios don't come out this nice. They will be quadratic equations, but you will not be able to factor them. Like you wouldn't be able to find two numbers that multiply together to be this and add together to this. There's got to be another way to solve them. We'll learn that in another chapter, right? So, all right, so that's 2 seconds. Then put 2 in to that formula to find the maximum height. Make sure I punched that in right. Did we get 256 back? 256 what? You notice I'm not showing any work on that either. You know, it's like I'm just putting it into the formula, into the calculator, right? So I need the work shown on the 2 seconds, though. Please show me the little formula. Show me the negative 64 over to the negative 32, and then you clean it up, right? Cool. How long did it take for this to hit the ground? We are finding the the x-intercept by letting y equal 0. And take a wonderfully wild guess what I purposely made be a GCF on almost all of these every time. 16 or negative 16, however you want to think of it, right? Because I wanted them to factor, right? You know, but eventually that won't happen. So see if negative 16 goes in there. It might not. It might be like an 8 where we might have to frowny face factor this guy, right? But does 16 go into 64 and does 16 go into 192 evenly? Does? Cool. I'll let you finish, right? Factor out the negative 16 so you can keep that number in front of t squared to be a positive 1. 192 divided by negative 16, negative 12. All right? Need a squared on that dog. All right, so. And then that is easy factorable. It's negative 4. Thanks. I got you. My bad. Should be a negative 4. Correct? Right? Minus 4t. Yes, yes, yes. Cool. You got to find two numbers that multiply together to be a negative 12 and add together to be a negative 4. So that would be a 2 and a 6, but the 6 is negative. And then x could equal negative 2 or 6. And then you're probably going to get an extraneous answer. Show him, but cross him out, right? Extraneous means it makes no sense for this scenario that it took this ball or whatever they threw, this projectile, negative 2 seconds to hit the ground. Doesn't quite work that way. makes sense algebraically, doesn't fit. Can you make sure we label our axes? This is time in seconds, and this is height in feet. And then plot 0 right now. Start with your y-intercept, like how high this guy was originally, your initial height. 0, 192. It was 192, wasn't it? And then sketch him going up for a little bit to the vertex, and then he comes back down to the ground to 256 and 60. Isn't that like amazing that it took exactly 6 seconds for that to hit the ground? Like realistically, that will never happen. It'd be like, oh, 5.9132 seconds. You know, it's like it's going to be decimally amounts. Why did it come out so nice? Because I engineered these formulas to come out nice with my brain. All right, let's do some homework.